All right. Testing sound. All right. Are we here? Oof, my hair is getting crazy these days. All right. Good afternoon. Wherever you're calling from, how's everyone doing? Saeed, welcome. What's up? All right. What do we got going on this afternoon? Well, as I said this morning, we're going to continue this afternoon with object-oriented programming. We were working on the Learning C# playlist, Learning C# for computational designers, and we were halfway through completing the section talking about object-oriented programming. Hey Andres, good afternoon. So this afternoon we're going to be talking, so we did this morning, we've talked about what objects and classes are, the concepts, how to implement basic ideas, how to create fields, so variables that live inside of objects, how to create methods, so functions that live inside of objects, and then like a couple of advanced topics on those two. This afternoon we're going to take a look at a couple of more advanced topics on top of object-oriented programming in C#. A lot of what I'm going to teach this afternoon is very C# specific. So many of this, I will try to make sure that I explain what is specific and what is not. And even though what I'm going to be talking this afternoon is a bit more advanced, I typically don't like teaching these things so early when we're learning computer programming, because I think sometimes like learning all these new concepts, like it takes some time to sit them down. And if I introduce advanced topics, it's a little too much perhaps. But these things that I'm going to be talking about this afternoon, I'm going to be talking about them specifically because it just so happens that many of these topics show up very often in popular programming environments, C# programming environments for computational design, like Grasshopper and Rhino, like Unity, and like some other topics. So they make a lot of use of what I'm going to be explaining this afternoon. So if we are going to be looking at those frameworks in the future, we'd better just learn what we're up to before we actually start facing these things. And I have to say like, hey, well, I don't know where this came from, etc. Or like, we haven't talked about this yet, but this is how you do it. You know, I don't really like those things. So let's try to build a solid ground, and then hopefully through practice and through many other geometry gems and algorithmic modeling. We haven't done algorithmic modeling challenges in a while. So we gotta get back to that. Yes. Good evening from Boston. I'm not sure how to pronounce your name, Aston, but good afternoon. How are you doing? Okay, so this afternoon we're going to talk about properties in classes. We're going to talk about static methods and static properties. We're going to talk about structs as an alternative to classes, and we're going to talk about the concept of passing elements by value or by reference, which is a confusing topic sometimes. And then once we get those 4 videos in, I'm going to build a full class from scratch for vectors. So in computational design, we do a lot of vector algebra. It's a very common thing to do. So I'm going to write a full-blown vector class that we could use and we could bring into other programming environments, and with like dot products and cross products and lengths and like all the cool stuff. All right, and I'm going to use that as a vehicle to going over all the topics that we have discussed in the series yet, and to explain a couple of other topics that I will not cover explicitly on the videos, like operators, overrides, and that kind of stuff. So shall we get to this? And then by the end of the stream, I will do like 5 or 10 minutes of social and Q&A for those of you interested. All right. As a reminder, we have a Discord channel. I posted links to that Discord channel in my previous video. Maybe I can post it again here. All right, I'll do it again. Discord channel. We also have a calendar, a Google Calendar for when we go live. If you follow Parametric Camp on Instagram, we typically announce also when it's going to happen in stories. And if you like what you're seeing, just consider clicking subscribe, like, notifications, those kind of things, you know. It helps us have a bit more of YouTube exposure, which is a good thing. All right, shall we get to this? Where are we going to start? Properties. All right, so properties. What are properties? Properties are confusing. But let's, so I have created here, how are we going to start talking about properties? Let me actually, okay. So how am I going to explain this? All right. All right. I'm going to talk about them in relation to fields, and I'm going to do it by discussing getters and setters, right? So, for example, uh-huh. All right. Okay. I think I have an idea of what I'm going to do. All right. So let's get started. I'm going to. It's probably going to be a bumpy start. Okay. Let's get started. Alrighty. So. All right. So, okay, let's keep talking about other topics that relate to how do we implement object-oriented programming. If you're here on this video, coming from the Learning C# series of videos, what I want to say is that with anything that you have seen so far in this section with classes, objects, and object-oriented programming, you're probably good to go. Everything you've seen, fields, methods, and all these other, those are the basic ingredients of writing object-oriented programming code. So you're probably good to go. In the next videos, I'm going to be describing a few more advanced topics that relate more specifically to how these techniques are implemented in C#. And I'm going to be doing that because it just so happens that many of the computational design frameworks that I typically use and that I think are popular among computational design just happen to use a lot of these techniques that I'm about to explain now. So even though they're a little more advanced, I'm going to explain them just because you may encounter them very commonly in C# based environments. These techniques might be different in other programming environments, so I will try to be specific about that. Okay? So for example, one thing that I would like to talk about in this video is about the concept of properties in classes. All right, and the idea is that we have discussed here how we have, when we want to describe characteristics of or things that an object can contain, what we do is we declare these variables that live inside of the class and that define what are the things that define a person class, for example, a person object. And we have named this as fields. Fields is the technical name in C# that we give to variables that live inside of a class. But I've also explained that C# has this concept of accessibility, the idea that any field, any constructor, or any method that you might write inside of a class has to be this accessibility tag called public, and there are other ones, internal, private, etc., that define who has access to reading or writing that particular piece of code using that variable or using those methods. And this is very important because C# is very much a production-oriented language. It's very popular for Windows-based applications. And it turns out that when you're writing big programs that have a lot of things talking to each other, etc., it's actually important to be mindful about which parts of the code have access to which other parts. Because you may, if everything is accessible to everyone, you might be vulnerable to things such as like code injection or like messing with the system, etc. So that's why C# implements a lot of structures to prevent people or code that shouldn't be accessing certain things from other things. It's also a very good practice by design, because you may want to create a class person and you may want to give people who are using person objects the possibility of changing certain things, but not the possibility of changing certain others. Because if they did, they may lead your program to be unstable or to work in a way that is not logic according to your design. All right? So this is where the concept of properties came in. The idea is that in C#, this is very C# specific, it's very common to keep information, so keep variables, keep fields, keep things that define the properties of an object, to keep them private, to keep them not accessible to the general world of who writes code for this, but to create this kind of like controlled doors or controlled gates or control ways of accessing who can read and who can write to those particular fields. I'm going to put an example. For example, in this case, we discussed the concept about how when it comes to people, all right, you may want to know their age. But we also discussed how if what we store in a person object is the age, then it turns out that the code will not evolve over time. And if I run this program now, or if I run it in 5 years, that object will not have changed. So it's much more interesting to store internally the year of birth of a person object, and then with an algorithm calculate what the age of that object is anytime you run the program. All right? We have done that before by using the getAge method, which is perfectly fine, all right? But we may actually want to create something that feels like a variable, that feels like a field in the person class, but it's not really like that, okay? So, for example, a very common pattern that you're going to see in C# is doing the following. If you have whatever fields you have for an object, what you typically do is you make them private, all right? This is a super common thing. You make them private so that only the code that lives inside of the class has access to changing the values of name, the values of year of birth, the values of height, and the values of whether if it is alive or not. Okay? Now, and another very common, and this is just a convention, it doesn't have to be like that, a very common convention is also to add an underscore to the beginning. I'm actually going to refactor things here. So I'm going to rename this variable here, and I'm going to rename it with an underscore at the beginning, all right? So same thing here, I'm going to rename it underscore year of birth, control R, underscore height, and control R, underscore is alive. The underscore means absolutely nothing. It's just a convention. It's a convention so that people who read this code have a sense that this is a private field and that it will only be accessible inside of the class, that nobody outside of the class can use this. By making all of this private, what I have done is I have effectively capped the access that anybody outside of this class has to the properties of that object. So for example, if I were to write here, I want to print to the console, I want to print the name of JL. You can see how as I type JL dot, you can see that this is not, where is the name? It's not accessible anymore because it's private, because I just made it private, okay? So what is very common to do is to write properties, all right, that are basically the gateways to reading and to writing fields, all right? Think of them as fake variables, or in a way, think of them as variables that have another variable in the back that is actually the one that is holding that data. So for example, it's very common to say, let me create a public string property that I'm going to call name. And this one, I'm going to uppercase it because it is just a convention as well. In C#, it's a convention to uppercase constructor names, to uppercase method names, and to uppercase property names. All right? And then what I'm going to do here is I'm going to say this property has two things that it can do, because I can read. I want to be able to give permission to anyone to change, to read, and to change the value of name. So what I can do is I can say I can have a get property that is going to give me the value that I'm using to store name. I forget. How do you write this now? Get equals, and then you return name, right? And then you got, no, you don't need a semicolon, and then you set, and then name equals value, right? Mm-hmm. Yeah. Mm-hmm. Mm-hmm. All right. Sorry, I forgot about how to do this. I don't. You never. I never. No one ever does this manually anymore. This is not a common thing anymore to do. All right. So, and then now that I'm saying that name can be used to get access to the value that I'm actually storing in the back, which is called underscore name, then I'm going to use name and say, whoever wants to get the property or name, what I'm going to do is I'm going to return the value that is stored in my private property, in my private field, underscore name. Imagine like going to the bank and saying like, hey, can you give me some money? And then somebody goes to the safe, take that money and give it back to you. But you have to go through this like intermediate person to make sure that there is like a safety procedure in between. All right. And similarly, what I can do is I can say, well, if I did only this, then anyone, look at what's going to happen. I can read now my name property. Oh, sorry. My keyboard is a little crazy these days. All right. I can now read my name property. Sorry. I can read my name property and print it to the console. So for example, I can print this here and you can see that I can get that value. But name is not really a variable. It's just something that is a gateway to returning the value that is actually stored underneath, which is underscore name. And if I wanted to change that, if I wanted to say jl.name equals now jl, you see how this doesn't let me do that because it cannot be assigned to. It's only read only. What I'm doing with this is that I'm forcing this to be only a read on property. If I wanted to be able to change it, what I would do is I would say, well, I want to also have a set access to this. And what I want to do is whenever somebody sets a value for the property name, what I want to do is I want to say, all right, so then go to my internal name variable, so this dot underscore name, and just store whichever value has been given to this property name. Value here is a keyword, so you have to use the word value, and the word value is representing whatever has been given to the property name. All right. So now this lets me do that, and so that I can have one name and then I can have another name, and if I run this, first this was called Jose, now it's called JL. All right. So again, this property is just basically a gateway, or like something that mediates how external code gets access to the internal variable that we're using to store the actual name, which is underscore name, which is private and cannot be accessed from the outside. Let me show other example. So for example, the year of birth, not going to use it because I don't want people to be changing the year of birth at all. That is probably something that has to be immutable. People may change names. It's difficult, but it can. People cannot change the date of birth whatsoever. It's just not possible. All right. Height, I'm also not going to give it. I may want to use functions to change that. And is alive, I may want to be able to give people the possibility of reading that property, but I don't want to give people the possibility of changing it manually. So what I'm going to do, for example, is I'm going to write a public property to give access to this. It's going to be a Boolean, and it's going to be called is alive, and I'm capitalizing both things because it's just a convention. And then I want to have here a get property that returns the value of is alive. All right? Very simple. Now, what is interesting about properties? The interesting thing about properties is that I can use them to create smarter access to internal properties. So for example, let's go back to the year of birth situation. I said that year of birth should be something that cannot be changed at all because it's probably how people work. It can only be created, it can only be assigned when you're creating the object, right? So that's something, that's why I'm going to give permission to whoever creates objects to use the year of birth. However, what I may want to ask to any object any given time is their age, right? The way I've done that is by using this function here called getAge, which returns like the computation of the year that we're now minus the year of birth, right? So this is fine, and this is a very common way of doing this. But very often in C#, you will also see this very same idea, the idea of calculating on the fly the age, but not being able to change it. You will get it, you will also be seeing very commonly these things implemented through properties. So for example, let's say that I want to implement here, in properties, I want to create a new property that is going to be called the age, and I'm going to uppercase it just because of convention, right? Age is not going to have a set. I'm not going to be able to change the age of an object. I'm only going to be able to give permission to get that age. However, the way that is going to happen is that I can't really now read the age from anywhere in my class. What I have to do is I have to perform that calculation of saying date, time. I have to compute which year are we now. I have to subtract the year of birth of this object, and then that's what I want to return. Which is very interesting because now I have the possibility of saying, well, can I print the age of this object? But think about this, I'm not setting that age anywhere. It's calculated on the fly as I request for this property. All right, it's giving me the value, which is using the year of birth to calculate that. But what's interesting about this is that the way it's written, j.h, it feels like it is a variable. It feels like it's data that is living inside of the object, but it's not really. It's something that gets calculated on the fly. All right. So this is also a very, very common pattern that you will see in C# very often. All right. Now, if I can make this a bit more complicated as well, all right, there are some shortcuts. So this is the archetypical way of giving get and set access to an internal variable underscore name through a property uppercase name. All right. Now there are some shortcuts to this. So C# has the the arrow notation, which is the arrow notation that basically indicates like return. So I can shortcut this that I had here is the exact same thing as writing this arrow and say whoever requests a get from this property, they should get the value of underscore name. It's the same thing. It's just a shortcut to writing, all right? And then I believe that set also has a shortcut, which I'm kind of blanking right now, and I'm looking at my cheat sheet here in the back. Yes, so the shortcut is that we can write this. We can say whoever requests set, just take the value of this name and store the value of value. Okay. Similarly here, we can just say this should be that, all right, and age should be get should be just give me back this result here. All right. So these are just shortcuts that I have here. Okay. But very if I can make this even more complicated, all right, a super common thing as well is that because there are a lot of variables inside of objects that we want to give users read and write access in a very normal way, like this, like name. So if you call name, just get the underscore name. If you want to change it, then save it into underscore name. So if we had a class with 17 different fields, and we wanted to give read and write access to all of them, it would be kind of a nightmare to copy paste these things 17 different times, right? So actually, it's very common to say, well, if you have a property that people can read and write indistinctively, and that there is no problems with privacy, there is no concerns, it's just, I don't know, like the X and Y and Z properties of a vector, for example, who cares? You can change them. That's what you want them for, right? Then, if you want to define them as properties, the even more typical way of doing that is by saying, I'm just going to say that this string name, I'm just going to remove everything. I'm going to say this is going to have get and set permissions. All right? And then this, I just don't need it anymore. I don't need it anymore because name itself is going to act both as a property and as a field. It's going to act as having as its own thing. It's basically going to it mediates who can read and who can write, but also it just stores the value on its own. All right. I'm going to undo that because I basically now broke all of my code. All right, and because everything was referencing the underscore name. But yes, so I'm just going to leave it how it was. All right, like this. All right, but just so you know that it's a very common pattern to do like a property that is both a getter and a setter, and that is also what stores the actual value of. And this is actually the most common way of writing properties inside of classes. Okay. All right, and I think with that, we can move on to the next topic. Is that correct? Let me see my cheat sheet here. Yes, I think that's probably fine for now. Okay. All right, see you on the next video. All right. Was that confusing? Huh? What do you think? I know, but it is what it is. It's a very C# thing. Okay, properties. Okay, I'm going to bring back Jane, I think. I'm going to bring her back, and I'm going to create a new file. I'm going to create a new project. It's going to be 55. It's going to be static properties. Statics. Okay, I'm going to save that. Said is mind blown. Pavel, not sure what happened. I don't know. I'm not sure. I know these things are actually quite useful when you're writing like very heavy production grade programs, but for beginner level, it's just not a great thing. But it is what it is. It's out there, so you can, at the beginning, you can just forget about it. It's not very important, really. I'm going to bring back Jane. Okay. And she was born in 2000, right? Uh-oh. Keyboard problems again. Oh my god. What have I done? Developer PowerShell? What is this? All right. Jane, year 2000. Okay. All right. All right. Mm-hmm. Mm-hmm. And then I'm going to write Jane here, and then we're going to run this, and we have Jane, we have true. All right. So we're going to talk about static stuff, right? Okay. Mm-hmm. All right, let's take a look at another, perhaps a bit more advanced topic when it comes to C# programming. And again, what I'm going to talk about right now is a bit more C# specific. Different programming languages treat this topic in a different way. So just keep it, this is a very C# specific thing. And it is the fact that I have explained in the previous videos how when we create properties and when we create methods, right? We do them because what we want to do is we want to create templates that define what kind of properties and what kind of activity or what kind of functionality different objects have. All right. So for example, if I say I'm going to console write line JL dot name, we know that the name property belongs to this particular object JL, and that has a different value than if I were to use it, if I were to call the name property of Jane, right? So here, this is Jose, this is Jane. So this property the property name belongs to the JL object and the Jane object. All right. And similarly, there is functionality, right? For example, if I say Jose Luis greet, right? And then if I say Jane.greet, we know that these two methods belong to the objects, and therefore they will have different outcomes depending on which object is the one that has been asked to perform that functionality, greeting. All right. But so this is the most common by far way of designing properties and designing methods, designing functionality in object-oriented programming. But it's not the only one, because what these two paradigms are, creating properties and creating methods for objects, the technical term in C# is that this here is an instance property, and this here is an instance method. And they're called instance because they do belong to the particular instantiations that we make of the general class. So name belongs to all the objects that I can create, and grid belongs to all the objects that I can create from the original class called person. All right? But it turns out that I can also create, and this is a little confusing at the beginning as well, I can also create properties and I can also create methods that belong to the overall general class but are not shared, they're not part of the individual particular objects that I can generate from that class. All right? Wait, what does that mean? All right, let's think about this. Let's think about the example of when I was creating here. Remember in the constructor, we had a situation where we passed in the name, the year of birth, and the height of a particular object, and that's what we initialized the object for. And then when we were calculating whether if the object should be alive or not, what we said was, oh, this, we looked at the year of birth, and if it was greater than which year we are, sorry, actually this should be the other way around. If the year of birth is less than the current year, then this is true and this is false. Exactly. That was a little, sorry. So if the year of birth is less than the year that we are at, then this object should be alive, and this object, or the object should not be alive. Okay? And that's why when I create this, you see that both Jane and JL, they're both alive, and they both have the age of, they both have an age of 70 and 20. Okay, that's fairly reasonable. But what if I decided to say, Jose actually was born in 1978, all right? If that was the case, then his age would be 231 years, which could be the case, but it's a little strange, all right? So maybe we may want to decide that when we perform calculations for whether if objects are alive or not, we may also want to check if there is a limitation to their age. Okay, so if the maximum age can be, for example, I don't know, 100 years, 200 years, who knows, right? So something that we can do is we could say, well, maybe I want to keep here some variable somewhere that defines what is the maximum age. So for example, maybe I have here a private integer. Maximum age is going to be equal to 100, all right? And then I can just say, well, can I use, if this year of birth minus current year, so, or if this is true, and then, and if current year minus this year of birth is less than this maximum age, if this is true, then the object will be alive. So if the age is less than the maximum, then this object will be alive, right? So I can calculate that, and then here you can see that now this one is, Jose is not alive, but Jane is alive, right? So this is a calculation that we can do dynamically. However, this approach is not great, because one thing that is not great here is the fact that we are storing for each object, we are storing this value that is called maximum age, that has a value of 100, and it is the same value for all the objects, all right? That's not a terrible thing to do, but imagine that we were working with a database of millions and millions of people. Turns out that we will be super redundant by saying, well, for all those millions of people, I'm going to be storing the exact same number, 100, like millions and millions of times. And I'm going to be checking against that. It's going to be in different parts of memory. It's going to take up a lot of memory space. So it's not really a clean thing to do. So maybe what I want to do is I want to say, in general, for all persons, there has to be this one property, all right, that is called the maximum age, which all objects have to abide by. But it's not going to be something that is going to be stored in each one of the objects. It's going to be a property that is going to be global to all objects that belong to the person class. You see where I'm going with this? So the way to do that is by making that property, making it static. All right? Static prop. Oh, sorry. Sorry again. I'm having a really rough day with my keyboard. So making that property static. So I'm going to say static properties, and then I'm going to do is I'm going to create a public static integer value that is going to be called maximum age, and I'm going to initialize this to 100. As simple as that. What's interesting about this is that by adding the word static here, I have changed this property here from belonging to each one of the objects that I have created, to Jane, to Jose Luis, and the other 1 million people that I might do, and it now belongs only to the person class. So take a look at this. For example, if I click here Jose Luis dot maximum age, it doesn't show up. It doesn't show up because it's something that doesn't belong to JL, even though I made it public, right? Similarly for Jane, it doesn't show up. Max age, it doesn't show up. So how then can I read it, or how can I use it? Well, because it is something that doesn't belong to the objects anymore, but belongs to the class, the way to access that value is by writing the name of the class person dot, and then you can see how now I have this property here called maximum age, which belongs to the class, doesn't belong to any of the particular methods or particular objects. And if I click here, something is going wrong. All right. Yeah. So yes. So here I forgot to change this. So now this should be person dot maximum age. Okay. And then I can now go ahead and say here, and you can see how the maximum age gets printed here as part of the static, as part of the class. Okay. All right, so we can have properties that are global to all objects of the type person, and indeed they don't belong to any of the individual persons, they belong to the class, and we can access those properties by accessing them from the class itself, from person.maximumAge. And like any other thing, we can also make this a getter, a setter, private, public, etc., etc. And actually, I would argue that this could probably be a private thing so that no one else from outside can mess with this value. I'm not going to get into that. Now, I may also want to create functionality that doesn't belong to any particular object, but that belongs to the class itself. So for example, I may want to create a method that takes two people, all right, and calculates the difference, the age gap between those two people, all right? If I wanted to do that, I could either just make a function in my program that does that, and that would be okay. I could also add it as a functionality that belongs to the object. So I could create a method here that would say, for example, public integer compare my age to, and then I could pass in the like another person object and then compare the differences. But that sounds a little strange. So typically, the way that is done is by creating methods that belong to the overall class. So for example, static methods. So here, what I can do is, as I can say, I'm going to create a public static function that is going to return an integer, and that is going to be called compute age difference. All right, and then this method is going to take a person 1, and then another person 2, and then it's going to take those two people and it's going to compare their ages. All right, so how does that work? Well, what I can do is I can say let me create an integer here that is going to be called difference, and it's going to be equal to 1.age minus 2.age. And then what I'm going to do is I'm going to return the math.absolute value of that difference, because depending on the order, one might be greater than the other and this difference might be negative. Okay? So whoever calls this method and gives in two person objects will get their age differences. And now the way this can be called is by saying, for example, I'm going to call D is going to be the difference between those two, the age of these two people. And just like I did with static properties, where instead of calling them individually from a particular object, so for example, I cannot do JL compute blah blah age difference, that doesn't exist. Where it lives is in the overall class. So what I can do is I can say person dot, and then you can see how now I got this new function that belongs to the class, compute age difference. I can pass in a person object, so for example Jane, and I can pass in JL, and then it gives me, it calculates the difference between those two, and then I can compute D here, and if I run this code, you can see that the age cap is 211 years, which is kind of ridiculous, but yes, we're gonna go with that. I guess Jose is a vampire or something. I don't know. Yeah, well, because he's not alive. So maybe alive should not be Boolean. Should be like something that has different values. Like it's alive, it's dead, it's non-dead, it's an undead. You know. Halloween was last week, so I think I'm a little influenced still. All right. So, but here is the summary. Properties and methods can be made. If you make them static, you will make them belong to the class and not to the objects, and therefore you can use them as general functionality and general properties that can be shared and can be used by all the objects without actually belonging to them, which is very nice because it's a way of encapsulating functionality inside of the classes without having to instantiate it and being redundant in terms of memory space. And actually, if you remember when I was at the beginning of this section, when I was explaining the math class, and I was saying like, oh, it looks like this has property called pi and a method called round, etc. But you see that I am calling it actually on the math class. Well, it turns out that all these guys, all the square root, the max, the square root is a function that is a static function of the math class. Math is not an object, it's actually a full class. It is actually a class that almost only has static methods. And similarly for the console object, and pi, for example, is also is a static property. So this value of pi is going to be the same for all mathematics in the world, and it's not going to change. So that's why they made it also static. Similarly, console is a class, it's not an object. But console has a lot of static methods, and you can see here the get and set. So maybe I can actually change the background color of the console. I've actually never thought about that, you know. And you have write line, which is also a static method of the console class. So class and math are both classes. Sorry, console and class. Console and math are both classes. They're not method. They're not objects, but all their functionality and their properties are static. All right, and I know it's a little strange now. It's a lot to take at the beginning, but I just wanted to be precise with the terms. Okay. All right. So I think with that, again, This I'm explaining because you will very often find in C#, it's a very common pattern, to wrap functionality, to take a lot of different methods, a lot of like different ways of calculating things, and putting them together in a class that becomes like this container of functionality. All right, and actually many classes cannot even instantiate objects; they're sealed. Sorry, sealed. No, that sealed is not the term. It's they're what is the name? I forget. There's a name for classes that do not allow instantiation. I forget what it was. Anyway, you'll see this a lot. That's the bottom line. Okay. All right. Let's move on to one of the last topics before we get into writing a full example of a full-fledged class. Woo-hoo. All right, that was a lot. I hate explaining static stuff. I think it's very non-intuitive. But whatever. Okay. So I'm going to create a new project. Um, um, all right, how's everyone doing? Are you holding on? How was the static stuff? I'm always concerned about these things. Did the message go through? Was it difficult to understand? All right. I want to talk about structs. Mm-hmm. And let me just real quick type. Hey, Spunky Dead Cat. How are you doing, sir? Uh, okay, let me see if I'm going to public double real get set and public double imaginary. No. Okay. I need to get a new keyboard. It's about time, right? Probably going to be a Black Friday upgrade. Is it equals real? This imaginary equals imaginary, and then public override to string return. I'm going to return. What am I going to return? I'm going to return real and then imaginary, for example. Does this work? I wonder if this works. New complex -5. Okay. If I run this code. Alrighty. Not bad learning at work. Okay. Can you also show one simple example of Grasshopper C# editor? It's somehow very wired code editor, not similar to Visual Studio Code editor. I think I will be showing examples of that next time in the next live stream, Kartik. So whenever we go back, so an example of a simple example of what? Of how to write classes in the C# editor? Is that what you're asking? Uh-huh. Um, yeah, the only difference is that you have to write your classes outside of the main function, of the main write script function. You have to write them below what it says. Additional code goes here. But that's the only difference. And the difference is also that you cannot exchange custom classes between Grasshopper components for reasons that I will explain at some point. But everything else is the same. So we may see examples of that in the future. I just don't want to mix in this series. I just don't want to mix Grasshopper stuff. I want to keep it like pure C# in Visual Studio. But we will also see examples of that once I create the C# for Grasshopper kind of playlist thing. Okay. All right. Okay, so I think I'm just going to start with this example here. And this could very well just be a class. All right, but I'm going to turn it into a struct. Okay, let's get going with this. All right, another perhaps like a little bit advanced topic that I would like to cover today in this series is the concept of structs. Okay, and you can think of structs as a super similar concept to classes and objects. And the idea is that some languages, and for example C#, they make difference between different types of classes, if you will. All right. So what's the idea here? For example, I have here a console application where what I have done is I have created a class that is representing complex numbers. I don't know if you remember that from mathematics, but you don't even have to. Just complex numbers are numbers that have both a real part and imaginary part. So that's super simple. So I have created two properties that can be read and written to. I call them real and imaginary. I have a constructor that is called complex. You pass in two numbers, they get stored in these properties, and then I have a toString method that lets me print to the console, that lets me stringify this object very easily. And then here I can just say, okay, let me create a new object of the type complex, and this is going to be a new complex, for example, 3 and -4. All right. And then if I print to the console this complex number, I should get something, you see, 3 and -4i, because the imaginary part is very typically represented with the letter I. I have chosen to create a class that represents this concept, complex numbers, right? And I could add more stuff here, how to operate between them, how to compute the argument, the modulus, like a lot of stuff, right? But that's not the point here. The point is that in C# world, very often by design. If you don't really care about these things, just stick to using classes forever. It's not really a big deal. But you will very often find in certain environments or certain frameworks that some people choose to implement different types of things. Instead of using classes, they choose to use this other thing called structs. All right? And you can think of structs as conceptually the exact same thing as classes, right? The exact same thing. When you define a struct, you define the pattern, you define the template of what properties it's going to contain, how do you construct it, and then what functionality each one of these structs has. All right? So it's the exact same thing, and you also create it, and you instantiate it, and you use it the exact same way as you would use classes. And actually, if you've never heard about this difference, but you've been using C# already, you probably have used structs and classes, and you haven't even noticed the difference because it's not a big deal. Okay, so I just want to say that this exists, all right, and they exist because there are some reasons why, for, let's say, simple classes or things that do not have a lot of complexity, or especially classes that do not store a lot of information inside of them. So for example, they only have like XYZ, or they only have real and imaginary, or they only have like very little data that actually needs to be stored with them. Structs are typically a popular structure to use for these kind of entities. And that is the case because there are a few very, very subtle differences between structs and classes. One of them is where they are stored in memory and how fast they get garbage collected or not. All right. And it just so happens that for very small objects, structs are a bit more optimized than for large objects. So if you have, for example, a point class, a vector class, a complex number class, those are typically represented with structs because they're lightweight. If you have an object that represents a lot of stuff, like the console class or the math class, whatever, then you go for classes with that. And the other big difference, and this is what I will explain in the next video, is that, and this is probably the most important one and one of the main reasons why they're used, and it is the fact that when we inter-exchange structs between methods and between different functions, they get passed by value, as opposed to when you exchange objects that come from a class in between different methods, where those objects get passed by reference. Now, what does that mean? That is exactly what I'm going to explain in my next video. Okay, so for this video, I just want you to know that there's this thing that is called structs. They exist. They're a bit more optimal when you're working with very lightweight objects or things that do not really need to store a lot of information. That's kind of the rule of thumb. But if you don't really care, in C# world, you will be absolutely fine if everything that you design and you declare is classes. Okay, so don't bother too much about that, and don't bother too much at the beginning with deciding, oh, should this be a struct or a class, blah, blah, blah. I think this is more of an advanced topic at this point, okay? Just so you know that they exist. Let's take a look at what passing by reference and passing by value actually means, because that is actually quite important when it comes to computer programming. Let's take a look at that. All right, Spunky, that is a very good call. Long's videos are really good. And he talks about those things, yes. All right, so so let me create another Visual Studio project, and for this one I'm going to bring in the person class and the where are we? 57. 57 references and values. All right, so let's do that. And I'm going to bring in, what am I going to bring in? I'm going to bring in the complex struct. And I'm going to bring in a lightweight version of the person object. All right. Yeah, I'm going to remove all this stuff here. Um, okay, and I'm just going to use the age. Okay, yes, there's age. All right. Public class, and then string name and string age, public and public, and this is just, I'm just going to remove all of this and all of this, and just like a super simple class, you know. Okay. Okay. All right. So all right, person JL is going to be equal to a new person. Mm-hmm. Okay. All right. I think. And then, yeah. Okay. I think I'm ready to start. Yes. Mm-hmm. Okay. All right. And let's talk another, perhaps a bit more advanced topic, but I think this is probably the most important one in this whole series, which is the notion of passing information by reference or passing information by value between different parts of my program, and what that means. All right. So let's talk about the problem. First of all, I have this example here that I've written as a console application that right now has three variables. It has an integer called number. It has an object of the type person and for this I'm using like a simplified example, a simplified version of the classes for people that I have written in my previous videos. So this one only has name and age, nothing else. No year of birth, no nothing, just like a very simple class. And in this other, I have another variable that is called x, and it's a complex number with real and imaginary parts. And this is the one that I have developed in my previous video. And with the only difference that this is, instead of being a class, is a struct, okay? But everything else is the exact same thing and it works exactly the same, all right? Now, let's imagine that I wanted to create some functionality in this program that takes any possible input and it increases the main value of that input by 1 unit. All right, so I'm going to write a bunch of functions that take different data types, and whenever they take them, they find what is the most meaningful data point inside of them, and they increase that number by 1. All right, so how is that going to work? Okay, so let me start by creating a public function that lives in my program, and it's going to be called increase. All right, and then it's going to be a void function. It's going to return nothing. The only thing that it's going to do is it's going to take some data and then going to make that data grow by 1 unit. Let's start, for example, with the person. So let me say that this function is going to be able to take any object of the type person, and then whenever it takes that object of the type person, it wants to go to the main data, numerical data point inside of it and increase its value by 1. How does that work? Well, what I can do is, in my function here, I can say, I'm going to take person and I'm going to go to p.age. I'm going to take the value of the age and I'm just going to increase it by 1 unit. Whatever it was before, I'm just going to crank it up. All right. And then, sorry, I forgot, this needs to be here inside of the class. All right. So I'm going to, and now I'm going to see if this works. So I'm going to say, I want to increase the value of JL. Sorry, public static. You're right. I always forget about these things. Yes. So I'm going to increase the value of JL by 1. And then I'm going to print to the console, I'm going to print the value of JL. So if I do this, all right, you can see that the object JL, let me print it before and let me print it after. So I'm going to print JL before and then I'm going to print it after. So and you're going to see that the object JL before had an age of 100, then it was given to this function. This function took that object, cranked up the age by 1 unit, and now the object JL has 1 unit more on its age property. All right. So this feels natural, right? This feels like what it should be, because it's taking an object, it's changing it, and now that object has this new value. All right. So this that I just said is what is called passing an object by reference. Okay. And I will explain why that is the case. Because now let's take a look at a different example. Let's say that I were to, for example, write a method that takes, for example, public static void increase, and then this one is going to take an integer. All right. So it's going to take number, and then what it's going to do is it's going to say number needs to be increased by 1 unit. All right. So what I'm going to do is that now I'm going to say, I'm going to write line the value of number. Then I am going to increase the value of number. And then I'm going to print again the value of number. What I would expect probably is to have the value of 50 printed here and the value of 51 printed here. Correct? Let's see if that's how it works. Oh, it doesn't work. I get the value of 50 both times. All right. Why is that the case? If that is the case, because here this has been passed by value. I will explain what that means in a second. All right. And let me show you the last example. Let's say that I want to implement the same thing for the struct for complex numbers. So whenever I'm given a complex number, I'm going to increase its real part. So complex.real, I'm going to increase it by 1 unit. Okay. And then I'm going to do the same example. I'm just going to copy paste this. This is X. I'm going to increase it and I'm going to increase it. And then probably what you would expect is to say, oh, then the real part now before was 3. Now it should be 4 in the second line. But it just so happens that this is before increasing it and this is after increasing it, which means that this has not been increased at all. All right, so X has actually not changed even though we have increased the real part here, because this is also being passed by value. All right, so what does that mean? All right, so it just so happens that the way computers work is that when you create a variable of any type, right? Depending on what type of variable it is, they get stored in memory in different ways, but they also get exchanged between parts of your program in different ways. The way it works is that for primitive values such as integers, doubles, booleans, and strings, I believe also strings, but I forget because those are treated differently depending on different programming languages. I believe strings are also passed by value, but I'm not entirely sure. Don't quote me on this one. When it's primitive values, what happens is that you have the value of the variable here. But when a primitive value gets sent to a different method or a different part of the program, or what it gets sent is the value that is represented by that variable. It's not the variable itself. So when, for example, when we execute this line of code here, what reaches num is actually just the value of 50, but it's not the variable number, so that when this is changed, the value of 51 is then stored in that variable number in memory. That's not how it works. What we're sending here is a copy of the value that is stored inside of the variable, and therefore, because it's a copy of that variable, of that value, it doesn't affect the original variable that we had. So any changes that we make to number here inside of the function are not going to affect the original value that is actually stored in the variable number, because this here, this variable number, the variable is passed by value, aka as a copy, and instead of passing the actual variable. The same principle applies with structs. All right, when we have a struct, because structs are a bit more lightweight objects, if you will, like I explained in my previous video, when we send x to this function here, what gets sent is not the x variable. What it gets sent is a copy of the x variable that is copied, let's say, on the fly, so that we can operate with that in the function. But because what is sent is a copy, then any changes to that copy do not affect the original one. So any changes that happen here in this method are not going to affect the original variable that was used and sent to this method. This technique is also, again, is called passing by value, because what gets sent is a copy that has no link, no reference, no back tracing to the original variable, and doesn't affect the original variable. However, with classes or with objects that are derived from classes, a different logic applies. When JL is sent to this method here, what gets sent is not a copy. What it gets sent, if you will, is like, imagine an arrow that is pointing to where this object is in memory. So a pointer, for example. What gets sent is a reference to where this person object, so where JL is in memory. So that inside of this method, we're not working with a copy of JL. We're actually working with the JL object in itself. Because what we got wasn't a copy. We got a reference to where that was living in memory. And therefore, any changes that we make here to the person object are actually affecting the original object that was sent into this method. And that's why this is called passing by reference. All right? So I'm not sure if you've ever encountered this situation where you were sending stuff to a function and you hoped that function to change that stuff, but that stuff was not being changed in your original code. That's because that stuff, which was probably primitive values or structs, that was being passed by reference. Whereas when you work with classes and with objects, objects are always passed by by reference to methods. So any changes that you make to objects in a separate method will affect the original object. Okay? Now, please keep in mind, everything that I just explained is very, very C# specific. The concept of passing by value and passing by reference exists in all programming languages. However, each programming language treats different types of data in different ways. The rules in C# is that all primitive objects, integers, booleans, doubles, and I believe strings, but I forget, all right? That also changes between different programming languages. And all structs, they both always get passed by value. Whereas classes and objects that are derived from classes, they always get passed by reference. So any changes that you make to the object in another method will affect the original object. And this is a behavior that you cannot customize. It's part of how the program works, how the programming language works. So if at some point you were working with an object and that you were sending to a method and you don't want that object to change, you make sure that the code that you're writing in the method is not going to change the original object, or you make sure that what you change is, or you send to that method is a manual copy that you have made from the object, so that if it changes in the method, it won't change your original copy. All right? There are a lot of advantages and disadvantages to both things, but once you know how things work, what gets passed by reference and what gets passed by value, it's actually quite helpful to have this distinction. It's very useful and it makes a lot of things much easier. Okay? So I hope that was clear, and I think we're ready to move on to the next video. All right. A primitive type. Struct type. A class type. And then I'm going to move this here. Primitives and structs are passed by value. Changes to the objects do not change the originals. Objects from classes are passed by references. Changes to the object will affect the original. Okay. All right. I think we're ready. How was this? As Python user, I think I just started loving C#. That you are loving C# or that you're not loving C#. I forget how Python treats. This is something that you can probably Google right now. Just Google Python passing by reference and passing by value, and see and see what happens. The basic idea is that higher level programming languages like Python or JavaScript, because they don't make a distinction between classes and structs, there's no such thing. Then the way it works is that primitive values get passed by value, and objects are passed by reference. But that depends on each programming languages. Each programming language treats these things differently, so you need to make some research before getting into it. Okay. All right. So it's 3:30. I only have half an hour, and I want to make a vector class, but that might take a little longer. It might take about an hour. What do I want to do? What do I want to do? What do we want to do? Do you want me to build the vector class, or do you want to just call it off? I'm open to suggestions. It's probably going to take me like at least 45 minutes to do the full example that I have in mind. Let me know. Should we call it off, or should we keep going? Alright, and this is saved. Vector. Oh my god, you guys are insatiable. Okay, so if we were to do that, Spunky. Well, I have to say she's very hot. Yep. Let's vector class. All right. I think I'm just gonna do it, and maybe I make it a little faster. I'm gonna take a break. I'm gonna go get some water. All right, I'll be right back. All right. Let's make a vector class. Why not? Yes. Let's not leave unfinished business. It may take us. Yeah, we can probably not do it too long. All right. Okay. So how are we going to do this? I have a playlist here. I think we learned just after how to use this knowledge that will help to fix it. Yes, Said. I mean, practice makes knowledge. So all this stuff is fine conceptually, watching these videos, but then when you have to sit down and put it together, that's when it really sinks in. So I think that's why the vector example is going to be super, super useful. So, all right. So let's get started. Should I draw a vector or something on the screen? Okay. Vector class. All right. Let's get started. Ooh. Yeah, we're gonna do it because I drank perhaps a little too much caffeine today, so I think I'm ready for this. So, all right. Hi, my name is Jose Luis, and this is Parametric Camp. Welcome to this. Starting over, starting over. Hi, and welcome to this new coding exercise where I'm going to be implementing a vector class completely from scratch. Okay, my name is Jose Luis, and this is Parametric Camp. We do a lot of live streams and computational design tutorials and videos. And if you're watching this video, you are probably here because you've been following my Learning C# Introduction to Computer Programming for Designers, that series where we've been learning how to code from scratch. So this exercise is part of a section where I have explained object-oriented programming, and I have explained a lot of the techniques and nuances of how to create classes and objects and how to work with them in computer programming. Now, what I would like to do is I would like to take all that knowledge and put it together and wrap it up and make an example where we see all of that together working for a very useful example, which is writing a vector class. A class that contains information such as the x, y, z properties of a vector and a lot of operations that we can do with vectors, such as vector algebra, computations that are derived from this. And I would like to use this exercise as a way of solidifying all the information that we have learned in the videos that make up this section, object-oriented programming, but as well to showcase perhaps 2 or 3 more tiny advanced topics that I have not covered in the class, but that I will cover just by example while I'm writing this class. Okay, so if you're interested in learning how to write classes, and in particular how to represent vector operations and vector algebra with that, I think you're going to be very interested in this video. Okay, so let's get started. All right, so how are we going to get started? Well, we're going to write a class, and we're going to write XYZ properties. Okay. Right. Okay, the first thing we're going to do is I'm going to be implementing this class, this vector class, inside of a console application. But you can think of this as a class that could be inside of a library, inside of whatever. Okay, so I'm going to write here, I'm going to write a public class that is going to be called a vector. All right, and I'm going to try to be a bit more descriptive about text. So I'm going to be using a lot of comments so that we can so that we're really writing a nice class. So this is going to be represents a three-dimensional vector, for example. Okay. Now, what are the main properties that a vector is going to have? Well, I think basically they're going to be x, y, z. It's a very common thing to do. So I'm going to write here properties, and I'm going to say, well, the first one is going to be a public property of the type double that is going to be the x component. All right. And I described in my previous videos how when we write properties, we want to be able to define if people have getting or setting access, whether if they can read or write to these properties. And for x, y, z, we're going to allow people to change x, y, z, no problem. All right, so that's why it's going to have a setter and a getter property. Similarly, for this, I'm going to get for y is going to be a get set property, and for c is also going to be a get set property. All right, so this is going to be the basics. We have 3 properties, x, y, z. Now we need constructors. All right, and I say constructors because we're going to we want to allow people who create vector objects to create them in different ways. Probably the most common constructor that we may want to write is one that takes XYZ values and stores those values in the properties. Okay, this is a very common thing to do. So for example, I'm going to write a constructor that takes as an input the X, the Y, and the Z. Okay, and then I'm going to I'm going to add some actually, you know what, this is a lot. it's going to be very difficult to read, so maybe I do that by the end of the video, okay? And then what I do is I say this, I'm going to take the x value that is given to the constructor and store it in the x property of this object here. So this is a very common thing to do. This y equals y and this c equals c. So everything that has been given to me as a constructor, I'm going to store it as x, y, c values, all right? And then in my main class, I can now start creating a couple of simple vectors, such as, for example, I'm going to create a vector v1 or v0, and it's going to be new vector with parameters 1, 2, and 3, all right? And vector v1 is going to be a new vector 4, 5, and 6. I don't know. Okay, I really don't know. And then console write line, and then read line, so that we stop the read key, so that we stop the execution. And then I'm going to print to the console. I'm going to print to the console the value of v0, and I'm going to print to the console the value of v1. All right. And as I do that, we're going to see that I get some really crappy printouts. I just get the name, the namespace, and the name of the class as a printout. And that is because I haven't really customized how my vector objects get serialized to strings. I explained in my previous videos how I can add to my class, I can add some overrides to customize how each object gets automatically translated into a string. And I discussed how in C# we have this standard method called the toString method that I can override and say, whatever this was before, I don't want you to use that version anymore. I want you to use the version that prints out to the console a square bracket, that prints square bracket, and then the property x, all right, and then the property y, and then the property z, all right. And then I'm going to close the square bracket, and remember that this dot in C# is optional. I want to try to use it consistently. I just like it. I have a little bit of OCD, but if you don't do it, it's going to be fine, okay? Now I'm going to print this again, and you can see how now these two vectors get represented in a very nice way with square brackets and with the three properties of the vector, okay? All right, so we have the basics here. Let's see how we can empower our class a bit more. Sorry. So how am I going to copy? I'm going to add more constructors. Something that I may want to do is to give users who work with vectors the possibility of creating vectors also in different ways. Maybe not exactly using XYZ properties, but with other ways. So for example, a very common way to create vectors is to simply create empty vectors from scratch, right? It's a very common thing to just create a vector and then to just create it empty with all the values at 0 and then modify it afterwards. So if I want to be able to give that possibility, so maybe I can create a vector without passing any information, and then the vector gets initialized to the value of 0. Each component gets initialized to the value of 0. This is a very common thing to do. Another very common thing to do is, because I explained in my previous videos how classes get passed by reference, sometimes you want to make sure that if you have an object that you're giving a method, you want to make sure that it's not going to change your original one. So what you may want to do is you may want to pass a copy of that vector. So creating a new vector by copying XYZ properties of another vector is also a very common thing to do. So I'm going to create another constructor a constructor, and this is going to blow your mind. This is a constructor for vectors that is going to take another vector as an information. All right? So I'm giving it a vector, and what I want is to create a new vector that is copying XYZ properties from the other vector. So how can I do that? Well, very easy. I can say the X property of this vector is going to be equal to the X property of the other vector, the one that you just gave me. Okay? Another one is going to be this other y, and this dot c is going to be equal to other dot c. All right? And then let's see how that works. So for example, I'm going to create a vector here that is going to be called the 0 vector. And the 0 vector is going to be a vector that I'm going to initialize with no parameters. So if I now copy any, well, did I do 0 with an actual 0? I did. So I'm going to print this, and if I run this, you can see how I just created an empty vector. All right? And I may want to create another vector that is a copy of v1. And this is going to be equal to a new vector where I am copying from v1. So I'm passing v1 as data, and this object is being copied here. So copy of v1, and now you can see how my fourth vector, copy of v1, is a vector that has the exact same values as v1 because they have been copied. All right? So this is also a very, very common technique. All right? Next, what else can we do, or what kind of functionality can we add to our vectors? Well, I think very typically a super common thing to be able to calculate from a vector is its length, right? So how can we do that? Well, I'm going to add, for example, a method that is going to be called getLength, and it's going to return a number that is the length of that vector. So for example, public double get length, and this function is not going to need any data to work with because the only thing that it needs is to know its own, So what I'm going to do here is, first of all, I'm going to calculate, you know that we calculate the length of vectors using the Pythagoras theorem, and I have a video somewhere in my channel where I have done that, so you can check that out. It might be popping up somewhere here if I remember to add that link. And then what I can do is, first of all, I can calculate the square length. All right, and the square length is going to be equal to this x times this x plus this y times this y, and then plus this z times this z. All right, and then what I can calculate is the length by saying that has to be equal to the square root of the square length. And that's the value that I can return. I can return the value of length. So let's see if that works. I'm going to change the vector v1, and I'm going to make v1 3, 4, and 0, because I know that the length of that vector is going to be 5, because it's a perfect whole triangle. I don't know what the name of that is actually. So let me calculate here, for example, console write line v0 dot get length. All right, and let me calculate the same but for v1. All right, if I do this, you can see that the length of this vector is whatever that is, but the length of v1 is a perfect 5, which sounds like things are working well. If I were to calculate the length of 0, hopefully that will also be 0, right? So let me, all right, exactly, and that is also going to be 0. Okay, cool. So what else can we do? Well, turns out that finding the length by calling a method is a very common operation. It's a very common way of designing things. But it turns out that in C# world, there's also the possibility of creating properties that can only be read, okay, and that act as, let's call it like fake variables that give you the impression of variables, but they're not really like that. So it's a very common thing, for example, to say, here I'm going to create a new property. I'm going to call this length, okay? And this property is going to be have only a get property. This is not something that can be changed. And the idea is that what I'm going to do here is that whoever calls the length property of this object, what they're going to be returned is the result of calculating get length. What? Yes, so it's a very common thing to say, well, maybe you can calculate the length by creating a method that returns that value, or you can say, if I type v0.length, you can see that now I can also read the length property of this vector. All right, the functionality is the exact same thing. The only thing that has changed is the UI of the class, if you want, or which possibility are we giving people to access the length of a vector, whether if it is by using a method, by calling a method, or whether if it is by accessing that method from a property. All right. What is the difference? There's absolutely no difference. It makes no difference. It's more of like a perception kind of situation, right? So some people prefer this method, or some people prefer having actual functions that are called get length, get height, get whatever. All right. So I would argue for whatever you think it feels more natural to you. The only thing that I would definitely argue is that length has to only be get, because if you're letting people change x, y, z, then length, it's absolutely dependent on x, y, z. So you cannot really set the length of a vector without actually changing x, y, z. All right. But what I would also argue is that you choose one or the other, or maybe you want to have both. It doesn't matter. So, but I would like to just have one or the other to make code not very confusing. So what I'm going to do is I'm going to make this private so that nobody else outside of the function, outside of the class can call it, but this property, because it belongs into the class, can actually call the getLength method. All right? This is a design choice. There's no right or wrong here. All right? Let me add a little bit more of functionality. So when we add methods to classes, we can add methods that compute stuff from the class. In this case, for example, computing the length. And I have decided to keep the length as a property because it feels like it's a value that you should get from the vector. That's something, to me, that's a good UI kind of design pattern. I prefer to use methods for things that make changes or that act on the object and change that object permanently. But that, again, it's a very personal choice. It's like how I like writing my code kind of situation, all right? So for example, what I can do is I can write a function that takes, I can write a function that is going to take the vector and it's going to flip it. It's going to change its orientation backwards, okay? So what I can do is I can say public void reverse, all right? It's a function that is void. It doesn't return anything because what it does is it changes this vector permanently, all right? By flipping its orientation. And the way to flip the orientation is by saying whatever x is, make it minus x. Whatever y is, make it minus y. Whatever c is, make it minus c. Okay? And therefore, if I go back to my example, I'm going to clean up a little bit of my code here, or at least I'm going to cancel it. Do I want to delete it or do I want to keep it there? I don't know what I want to do. I'm going to delete it here. So you see how I'm printing v1 here? So if I now say v1.reverse, you can see that this code is changing. It's going to change the code, it's going to change the vector internally. So if I now print, for example, if I print v1 before and v1 after, you can see that is the same vector, but in opposite direction. I have reversed the vector. All right. So again, I personally like using this kind of like properties kind of approach to reading information. But if it is about changing the vector, I prefer using methods, because to me the idea of like, oh, I'm calling reverse on this object, it feels like it's calling for action on this object. All right. It's just a preference. But again, this is a design choice. You may have a different style of writing code, and that's perfectly fine. Another thing that I may want to do is I may want to scale this object, this vector. I may want to multiply it by 10 times, by shrink it by a half, whatever. So something that I can do is I can also say, well, I'm going to create a function called scale. And this function is going to be a void function because it's not going to return anything. It's just going to change the vector that I am at. And what I'm going to do is I'm going to say, well, I'm going to need some information. I'm going to need at least the factor by which you want to scale this vector. All right. So I'm going to say, this function is going to take a double as an input. And then this, what it's going to do is it's going to multiply the value of x by a factor. It's going to multiply the value of y by a factor, and it's going to multiply the value of c by a factor. All right, I'm going to multiply here. Does that make sense? So let's see. I have vector 1. I have calculated, let me just, for the sake of the example, v1.length. All right, so I'm going to calculate the length here. And now v1, I'm going to scale it by 0.5. All right. And if that was correct, the length of the vector should always also have been modified by a factor of 0.5. So let's see. I have the vector, I have reversed it, I have then scaled it, and let's see how that works. We have the original vector, then we have the flip vector, the length is 5. Now we have the half vector and the length is 0.2.5. So half that length, all right? So things are looking okay, all right? So things are looking okay. Now, maybe something that I may also want to do, and this is a super, super common operation, is to unitize a vector. What does that mean? Unitizing a vector means taking whatever that vector and whatever the direction is, keeping that direction, but then shortening it or stretching it so that the length of that vector equals 1. The way to do that is super simple. I think I have a video somewhere on my channel as well, but basically the way you unitize a vector is by dividing each one of the components of that vector by the length of that vector. So let's take a look at this. Public void unitize, and I don't need information here. And what I'm going to do is first I'm going to calculate the length. So double length is going to be equal to the get length method, so the return of get length. So I'm going to calculate the length of my vector by calling the length property. And yes, within a particular vector, I can also call methods that already live in that vector. All right. So within this object, I can use the method that already lives inside of this object. I don't have to call it externally. And what I can do now is I can say, well, then this dot x has to be divided by the length. This dot y has to be divided by the length. And this dot c has to be divided by the length. Okay? How does that sound? Is this making sense? Let's see how that goes. So I'm going to now here go v1 and I'm going to say unitize. All right? And then after that, I'm going to print again the name, the length. I'm going to print again the coordinates of that vector and the length of that vector. Let's see if that works. So here we have that when unitizing it, the components become 0.6 and 0.8, and the overall length has become the value of 1. All right? Awesome. This is great. However, a really tiny detail, and this is me being OCD, top OCD, if you take a closer look at what we've done for unitizing, all right, what we have done is that we have calculated the length, and then we are dividing each one of these components by length, all right? However, we have to be mindful about what's called corner cases. Corner cases are situations in our code that are not going to be often happening. That are going to be only like very, very once in a while happening. But if they do, they may actually break our code, or they may lead to unexpected results. What does that mean? Let me show you, for example, if I create a vector called 0, which is just going to be a new vector with 0 for each one of the components. And if I try to unitize that vector, look at what's going to happen. I'm going to run this code, and what's going on? Oh yeah, sorry. Let me print you the console. Let me print what's going on here. You see, what I just got is that the 3 components of this vector, now instead of being 0, they turn into nan, or not a number. So I basically destroyed this vector by trying to do a mathematical operation that is not allowed, that is dividing a number by 0. Okay? So 2 things that I should do here. First of all, one thing that I should do is I should calculate if the length, once I have calculated it, if the length is equal or less than 0. And if it is, I don't do anything. But if it's not, then I continue doing this. So I would argue that checking here if length is less or equal to 0, then I should probably not continue doing anything in this method. So what I should do is just return. All right? If I run this code now, you can see that now I don't get that error. Okay? And I don't get the error, and the vector stays with coordinates 0, 0, 0. All right? Now, also something that is very common to do is that and this is thinking about the design of this class, all right? Something that is common to do is to say, well, whoever is writing this code, whoever is using this code may want to know if the operation of unitizing was successful or not. Because if it was not, then maybe they want to make some other decisions. So there should be a way for the method to signify or to let the coder know if unitizing the vector was successful or not. The way to do that is very simple. So we can choose to, instead of not returning anything from this function, right? What we may want to choose is to return a Boolean value that represents whether if the operation was successful or whether if it was not. So if the length is less or equal than 0, then I may want to return false to indicate, hey, this didn't work. All right. However, if the operation was successful, then I may just want to return true here. All right. And then I can use this, for example, to make decisions here. So for example, I can say if the result of unitizing of this, if this was true, right, then I can print to the console success. Otherwise, I can print, oh, none, you know? And then, and similarly, I can do that here with 0 unitize, right? So I can be here 0 unitize and then print one or the other. So if I run this code, you can see here we have success, and this vector was unitized, and the length is 1. And oh no, sorry, oh none. And then the vector didn't change. All right, does that make sense? This is being already super picky and super overthinking these things, but we're trying to become better computational designers. So why not spend some time thinking about how do we want to use our code, and how do we want our code to be a bit smarter, right? All right. Mm-hmm. Oh, okay. What else are we doing? How is this going? Am I going too fast, or am I okay now that you know how to write classes, and how you know um, overall what I'm doing? How does that was fast, but it works. Okay. All right. Thank you, Pavel. um, what else are we doing? We're adding vectors together. Mm-hmm. All right, so let's add vectors together. Oh, thanks to you guys for sticking around. All right. Um, uh, all right, let's keep going. I haven't finished yet. So, what are we doing here? Yeah, so we're gonna add vectors. Let's keep going, and let's add more functionality to our vector class. Okay, something that is very common to do is to add vectors together. Okay, so one thing that I may want to do is I may want to have a vector, and to a particular vector, I may want to add a second vector. All right. So the way we're going to do that is super simple. I'm going to say public void add, and then what I'm going to do is I'm just going to pass to this vector, to this method, I'm going to pass as information another vector. All right. So what we're going to do is we're going to add two vectors together. And what we're going to do is to this x property, I need to add the x property of the other vector. To this y property, I need to add the y property of the other vector. And to this c property, I need to add the c property of the other vector. Let me clean up a little bit of the code here. Let me clean up all this stuff here, and I'm going to console write v0 and v1. And now what I'm going to do is to v0, I'm going to add v1. And the order of operations doesn't matter. And then what I'm going to do now is I'm going to write the value of v0, the value of the vector that I have used to add these two vectors together. Okay, and you can see that my v0 has now changed, and now has the value of 4, the value of 6, and the value of 3. So v0 has become the combination of v0 and the v1. Okay. However, and this is where things are going to, now I'm going to start getting into the more advanced stuff on this video. And however, this might be okay to do, because the way I read this code is, to me, is very intuitive. It's, I have v0 and I'm calling the add method on v0 and I'm passing in v1. To me, this feels like I am changing v0 permanently by adding the values of v1 to it. Okay, so that's great. However, I may not want to have I may not want to actually change the value of v0. What I may want to do is I may want to create a third vector that is the addition of both v0 and v1. So I may want to call that v2, and I may want to do something where I say I want v2 to be equal to the value of v0 plus v1, but I do not want to change any one of the original vectors. I want to keep those values there because I may want to work with them farther down the road. Okay? So that is where, for example, things such as static methods are a really good way to go. So for example, what I may want to do is I may want to create a function somewhere that takes two vectors and then creates a new vector that combines the x and the y properties of both and then makes a new instance of a vector. But again, without changing any of the two. For that, a good way to go is typically creating static methods in your original class so that that method doesn't belong to any object, but it's a general method, and then you can use it to combine things together, to perform calculations, etc. So I'm going to go all the way down here, and I'm going to write static methods. All right? So I'm going to write here a public static method that is going to be called addition. All right? And this addition method is going to take a vector called A and a vector called B, and I'm missing a return type here. What I'm missing, and this is where the moment comes in, if I have this method that I want to use to take two vectors, combine them together, and return a third vector that is new, the return type of this function is going to be yet another vector. So literally, this is a function that takes two vectors and returns another vector. As simple as that. And what is going to happen here is that I want to say, for example, I'm going to calculate new x is going to be equal to a dot x plus b dot x. All right? Double new y is going to be equal to a dot y plus b dot y. And then double new c is going to be equal to a dot c plus b dot c. And I'm going to create vector v is going to be equal to a new vector that is using those coordinates, new x, new y, new c. All right, and I'm going to return that vector. What just happened here? I declare three variables, new x, new y, new c. I use them to store the addition of the x, the y, and the c coordinates. I created a new vector using those added coordinates, and then I'm returning that vector as part of what this function here does. All right? Now, let's remember, I declare this as static. What that means is that whenever I want to use that, if I want to use it here, for example, what I want to do is I want to create a new vector v2 that is going to be equal to the addition of those two. Because that method is static, it doesn't belong to the object. So I cannot do v0 dot addition. No, this is the add, which is the previous one, the one that changes the object. The only way that I have for accessing that is by calling it directly from the class. So what I do here is I say type vector dot, and you can see that now I have this new functionality that is part of the class that is called addition. And then this takes vector A and vector B, so this is going to be v0 and v1. And because this returns a vector, the combination of both, I'm going to store that in this new variable that I just created. And now I'm going to say console write line v2, and let's see if that works. All right, so it looks like it's working. v2 is now a vector that lives in my program, and that is the combination of these two vectors. All right? Wonderful. So it turns out that we can use static methods for example, for taking two different vectors, computing some calculations, and then returning the result of those calculations. So let's do a couple more examples of that, because it's a very common and very popular, it's a very common pattern. It's a very popular pattern. So for example, what other things can I do? What other operations do I have between vectors? Well, something that I can do is I can calculate the dot product. All right. So what is the dot product? So if you remember, I have somewhere in my other videos in parametric camp, the dot product of two vectors is a number. Okay. So I'm going to say that the return type of this method has to be a double, and I'm called here dot product between vector A and vector B. And all right, and now what I can do is I can say, okay, what is the x component? Sorry, actually none. Sorry, the dot product, if you remember, you don't have to remember this, but if you remember, the dot product is the simple addition of all the components of the two vectors multiplied. So that is going to be a dot x times a b dot x plus a dot y times b dot y plus a dot c times b dot c. Okay, and I have a lot of videos in my channel where I explain why the dot product is so useful and so popular, and it's like in every basic operation. Okay, and I can just return this. I can return the dot product, or if I want to be a little cleaner, I can just say return this. Okay, and I can just do it in a one line, a one-liner. All right, so let's calculate the dot product between v0 and v1. So vector dot product is going to be between a and b. Sorry, between v0 and v1. And let's print to the console the dot product. If I do that, it turns out that it's a whole number. It's 11. All right, that's great. And yep. And what else can we do? We can calculate the cross product as well. Okay, fine, let's do that. So we're also going to create a new static method. So that's going to be public static, and then the return type is going to be a vector, because if you remember, the cross product between two vectors is a third vector that is perpendicular to them both, and whose length is equal to the area of the parallelogram that is formed between those two. All right. I have some videos also in my channel where I explain the cross product more in detail. All right. So vector A, vector B. All right. And then I always forget what are the calculations for the cross product. Let me look them up. All right, so I always forget the cross product. What is the cross product? Okay, calculating it is all right. Okay, I found it. I have it here on my side screen. So I never forget this, and I don't think anyone should remember how to do the cross product just mentally, but it's fine. What's important is to remember what the concept is, okay? So the x property of the cross product vector is going to be a dot y times b dot c minus a dot c times b dot y, okay? Double y is going to be equal to, excuse me, a dot c times b dot x minus a dot x times b dot c. Is that correct? I believe so. And double C is going to be equal to A dot X times B dot Y minus A dot Y times B dot X. All right? And then I can return a new vector with these X, Y, and Z coordinates. All right? I might be wrong here. I think this is correct, but don't quote me on this one. How can we verify this? Where if I create, for example, if I create a vector Vx, which is a pure vector in the one unit vector in the x direction, and I create a vector Vy, which is a new vector in the y direction, if I do the cross product of these two vectors, I should get the c vector. So let me do that. Why not? So vector cross should be equal to vector dot cross product between Vx and Vy. So let me print everything to the console. So that's Vx. So that's Vx, and then this is Vy, and this is the cross product. Let's see if this works. Woohoo! It looks like it works. So we get a vector that is perpendicular to these two, so in the c direction, and the length is equal to the parallelogram that they form. So because it's a square of 1 unit length, then the area of that is 1 unit. So that's great. So it looks like it's working so far. Okay? Now, this is actually a very interesting example. I'm going to clear all this up because something that is also super, super common when working with vector algebra is needing to generate quick or fast, needing to generate unit vectors in the x direction, the y direction, and the z direction to do simple operations like these ones. So instead of actually having to go through type in new vector 1, 0, 0, 1, 0, 1, whatever, blah, blah, blah. Actually, a very common thing to do is, and this is also, we're starting to get also in the advanced kind of ways, is implementing in the class, implementing static properties, so implementing global properties that what they do is they generate automatically these canonical vectors in a way that we don't need to manually use the constructor to create them. So for example, let me show you an example of that. We're going to go here to properties, all right? And I'm going to create a static property that is going to be called here, it's going to be of the type vector, and it's going public static, all right? It's going to be a static property. Static properties, static vector call, and I'm going to call it x-axis. All right, this is a very common thing to do. And what I'm going to do is, this is going to be only of the type get. So I'm not going to be able to force to write to this property. And whenever anyone calls the static property x-axis, what they're going to be given back as a result is going to be, they're going to be returned a new vector in the x direction with 1 unit long. All right. Or if you wanna do shortcut things, this is also a way to shortcut that expression. Okay, whichever one works for you. What this allows me to do is that now I can shortcut this a little bit by saying now instead of having to manually generate this x vector, I just want to go to the class and ask the class to give me you can see here a canonical x-axis vector. All right? So it feels like it's a property. It feels like it's always the same x-axis vector. It's easier to write, it's easier to type, easier to read. But at the same time, what's hiding under this expression is that the class is basically giving you a way, it's giving you a name to automatically generate vectors in the x direction. All right? Similarly, we can just create a y-axis this is going to be 0 and 1. And we can also generate a z-axis that is going to be an axis 0, 0, 1. Okay? And then I can rewrite this now to say vector dot z-axis. Oh, sorry, no. Well, let me say y-axis, sorry. And if I run this code, things work exactly the same. 1, 1, and then the other vector. Okay? All right, so this is looking great so far. What else can we do? What else can we do? Oh, let's take a look at manual operators. What? Oh, oi, how are we holding on there? X5, cool. Let's go and write another Rhino common. Exactly. Let's do it. We're doing it ourselves now. We're writing our own Rhino common, you know? All right. So what about defining a static function for an operator? Oh, we're going to do that exactly right now. Archie-coder. Very good. All right. So I forget what the syntax is. So it's operator override or something like that. Operator overloading. All right. So how does that work? Okay. Okay, so I'm going to rewrite this v2 equals vector addition v0 and v1. But what do I mean with overriding operators? Okay, so I have cleaned up a little bit of the old code, and I have gone back to where we implemented addition between two vectors, right? And you could argue like, oh, okay, well, I understand, yeah, vector dot addition, blah, 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 gives me a new one, right? But you know what? It's just adding two things together. So it feels like it would be super interesting to have the capacity to say V2 should just simply be equal to V0 plus V1. That's it, you know, so simple as that. But we can't. So this is giving me an error because it says like, oh, I cannot use the operator plus between two things of the type vector. I only know how to add two numbers. I don't know how to add two vectors. All right. So can we actually teach the computer how to use the plus operator to add two vectors together? Indeed. There is this thing called operator overloading. All right. We have not seen that on the previous videos that I have posted, or maybe if you're watching this in the future, maybe I already did a video on that, and what I'm saying right now is not true. It doesn't matter, but I'm just going to explain it again. The idea is that just like I have created methods and functions and blah 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 with their own particular names, what I can do is I can also override, or I can create shortcuts to teach the computer how to use operators that are common for other arithmetic operations, but instead of using primitive types like numbers, by using custom types that I have generated, like the vectors. So how does that work? Well, the way it works is that they are static operators. So what that means is that I'm going to go all the way down here where I have my static methods, and before the addition one, or after, it doesn't really matter where you do it, all right? What I can do is I can create I'm just going to create a operator overloads. And what I can do is I can say, I'm going to create a new public static thing. And this thing is going to be overriding the operator plus, okay? All right, but then the operator plus, I need to be the one who defines what are the two things that the operator can add together. So these are going to be defined as arguments of a function. So I'm going to say vector A and vector B, all right? I'm going to open and close curly brackets, but as everything in C#, because C# is strongly typed, it also needs to have a return type. So when I add two vectors, for us, it might be obvious that the result of that operation needs to be a vector, but for the computer it's not. So we just need to specify when we add two vectors with the plus operator, the result is going to be a vector. It's going to be something of the type vector. And what are we going to do here? Well, something that I could do is I could just copy paste this. I'm going to add the components, blah, 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 whatever, and then I'm going to return V. Or whatever I want, I can also, instead of being redundant with code, what I could do is I could say, I'm just going to call this method here. I'm going to call return vector.addition, and then the addition between A and B. So this thing here is going to be calling this method here. All right? So one is calling the other, or I can duplicate the exact same code on both of them. I don't like duplicating code, even though duplicating code sometimes is a bit more optimal in terms of performance, but not in terms of code maintainability. So I'm just going to keep it here. All right? And then by doing that, now you can see how I don't have an error here, vector v2, all right? And then I can console write line the result of adding these two vectors, which is 4, 6, and 3. Okay? Similarly, for example, I could override the multiplication operator. You know what? I'm actually going to return, so that it's a bit easier to read, vector addition A and B. I'm just also going to override the multiplication. So static operator, the multiplication symbol, and I'm going to say vector A and vector B. Okay? And what is going to be the result of multiplying two vectors? Typically, simple multiplication of two vectors is typically understood as the dot product. Therefore, the result of this operation is going to be a double. It's going to be a number. And then the return of this operation could be vector dot product A and B. So whenever I call multiplication on two vectors, what I'm actually doing is the dot product between them. All right? So here I could say double dot is going to be equal to V0 times V1. And now console and the dot product of these two. And I also get the value of 11 right now. All right? Even more. Wait. Let me show you another trick. When I multiply things, they don't have to be the same type. They can also be different types. So remember when we said that we could scale a vector, right? But when we did scale a vector, we scaled it in place. We changed that vector. But maybe what I want to do is I want to have something where I can say, for example, vector v22, so 2 times 2. I want this to be 2 times the vector v2. All right? So, and I want to be able to print that to the console. This is fine, but the problem is that I have defined how to multiply two vectors together, but I have not defined how to multiply a vector and a double. The computer doesn't know how to do that. All right? So the way to do that is by defining somewhere in the overloads an overload for the overload. So just like here, I have defined an overload for the multiplication symbol. and I have specified that this can take 2 vectors, then something that I can do is I can say, I'm going to do the same thing. All right. I'm going to say, oops. I'm going to define an overload, a static overload for the operator multiplication symbol, but this time it's going to be between a double A and a vector B. All right. And if I do that, the return type of multiplying a number by a vector is going to be a vector that is a little bigger or smaller depending on how it gets scaled. So the return type is going to be that. Okay? And then what do we do? Well, something that I can do is, for example, I can create a vector that is going to be called v, which is going to be a copy of the vector that has been given to me here. All right? Because remember, I may not want to change the vector v that has been passed here by reference. And then what I can do is I can say I want to scale that vector by the factor that has been given me as a number. So I want this to be the vector that I change, not vector b. So you see here, this is a good example of why I may want to make copies of vectors. And now I can just return v, and that should work. Let's prove that this works. So I'm going to, this is now working, but let me also print again v2 to make sure that it hasn't changed. All right. So we have v2, we have v2 multiplied by 2, we have v2 again, it hasn't changed, and we have the dot product between the two vectors. All right. How awesome is this? Huh? How cool is this? All right, and we're going to do the last thing, and then we're over with this. I'm going to show you how to do item access. All right, how to refer to the properties of a vector not by the XYZ, but by using array notation. All right, how awesome is that? Woohoo! Okay, so I need to look this up because I haven't done it in a while. Item operator. No, how item access overloading the square bracket over. Yes. Okay. Indexers. All right. All right. How are we holding on? Huh? Can you give me some thumbs up if you're still alive after all this stuff? Alrighty. I'm not sure what that means. I'll take it as a positive thing. All right. Okay. And yeah, indexers. All right. Yeah. And the last thing that I want to touch upon on this example is indexers. All right. I haven't shown that in my previous videos, or I may have written a new video that I'm not after this one. But the idea is that we can we can overload multiplications. We can overload addition symbols, etc. There is another another tool that we can add to our classes, which is the fact that we may want to be able to retrieve data from that class by, instead of referring to the name of the object, of the name of the property, we may want to be able to refer to some of the properties by using square bracket notation and an index number, just like we do for lists and for arrays. So, so I may want to do something where I may want to be able to get the x property of v0 by saying I want to take v0.0, and I want to do the y property, I want to do v01, and the c property v02. Okay? Why is this interesting? Well, sometimes we may want to write code that uses a lot of for loops and uses a lot of iteration to work with the object that it uses. So maybe we want to be able to pass in objects that accept being read using indexer notation. Okay, it's not a super common thing, but it's a nerdy enough thing, and it really fits the vector class, for example. So I thought that maybe we could just implement it. So it's actually quite an easy thing to do, and the idea is that the way to do that is by writing what's called an indexer. An indexer is a way of saying, if you give me square bracket notation and an integer number, then I know what to give you back from this. So what does that look like? The way to do that is by writing, I'm going to define a public indexer that is going to return a double. Okay? And what I do is I use the this keyword, and then I open square brackets, and I say, if you give me an integer that I'm going to call I, then I will know what to give you back. All right? And then what I can do here is I can say, if you want to read, okay, then what I'm going to do is I'm going to say, if I equals 0, all right, then return this dot x. Otherwise, if I equals 1, then return this dot y. Otherwise, if I equals 2, then I should return this dot c. Okay? And so this is the basics. However, this is giving me an error because since I have 3 conditional statements for 0, 1, 3, there might be the case where the user gives me a number that is not valid. So something that is less than 0 or something that is greater than 2. And in that case, my code would not return anything here. So I need to be able to make sure that I either return something. So for example, I can return null, or instead of returning null, I must be able to say, oh, I think you gave me something that was wrong, so I'm just going to throw an exception. I'm just going to throw a new exception. Okay? Period. So how does that work? So in this case, this code is going to work, and nothing prints out because I haven't really printed anything out. But if I were to say double W and I want to be v0.4, for example, and I run this code, you can see that I have an unhandled exception because something is not working properly. Okay? And then, similarly, what I can do is I can say, well, but if you want to write to these things, I can say, well, I'm going to copy this structure. If I is 0, then this dot x equals whichever value you're giving me. All right? And otherwise, this dot y, and then this dot c. And if you give me something else that is not 0, 1, or 2, then I will throw an exception. All right? And by doing so, what I can do now is I can say v0, 0, y. Sorry. I'm going to keep what I had here. And then v0 is going to be equal to 3 point blah, blah, blah. V01 is going to be equal to whatever, another number, and V02 is going to be equal to this other number. And let me print this to the console, V0. And as I do that, up, what have I done here? What have I done? V0, 1, 2, console write line 0, line 72, line 20. Okay, let me take a look at what's going on here. All right, can someone help me out here? What have I done? It's in line 20. And I have an exception at line 72 here, but it's coming from line 20, which is this one, which seems like it's not letting me do getter setters. But I is 0 here, so why can I not do that? So why is this just not working? So if I equals 0, then this.x equals value. Oh yeah, because I know, because all right, yes, because it's throwing the exception. Anyways, always. It's changing the values, but it's throwing the exception. Yes, okay. All right, sorry, I found the problem. It's a little late here. I've been recording all day. Yes, so because of the way I wrote the if else, the code changes the values, but it always ends up throwing the exception here. So what I need to do is I need to just wrap this into, if none of the above was true, if you gave me a number that is not 0, 1, or 2, then that's when you need to throw the exception. Not always, all right? And I think this code should work now. And yes, I do have this new vector with these weird numbers that I just created. Okay. All right, and I think with that I have covered everything that I wanted to cover, and I think I have given you a pretty good sense of an interesting and fairly comprehensive way of writing a vector class that has a lot of functionality about how to work with vectors, scaling them, unitizing them, overriding the operators, which is a really common and cool thing to do with vectors, writing static methods, and even customizing how they get turned into strings. Okay, there are more things that we can do. We can add operations on how to calculate angles, or whether if the vectors have like valid operations, or I don't know. There's a lot of things that we could add here, but for the sake of illustrating how to create a class, I think I'm happy with this level. And I actually think we touched upon some fairly advanced topics, many of which are very particular to C#, for example, operator overloads and that kind of stuff. So I think I'm fairly happy with this. So thanks a lot for sticking around to this video. My name is Jose Luis. This is Parametric Comp. We do a lot of videos on computational design. If you did like what you saw here, it would be very nice if you could hit subscribe and notifications, like this video, and show a little bit of love. YouTube helps us promote this content if you do. And if you like the overall idea of what we've done here, I recommend that you check all other videos that I have in the channel, where I do a lot of code with, especially with geometry mixed with code. We create form and all these other things. All right. Thanks a lot. I think I want to record that farewell again. I'm going to record that again. So my name is Jose Luis. This is Parametric Camp, and we do a lot of computational design videos on learning how to code and doing it in creative ways. So if you did like this video, please, it would be nice if you could subscribe to the channel, hit the notification button, like this video, and all those things that help us promote this content on YouTube. And if you also like the spirit of the things that we're touching upon, how to write code, for creative purposes, I have a lot of videos in the channel that touch upon other topics. For example, computational geometry, interactive things, algorithmic modeling, and all those topics that I think might be interesting for you. So you're welcome to check them out. In the meantime, thank you very much, and hope to see you in some other video. All right. Boo! How's everyone doing? Okay, I'm quite beat at this point. Oh, look at my dark shadow here. Okay. Um, not suitable for 18 years old. All right. Okay. Well, thanks a lot, everyone, for sticking around. It's been almost 3 hours. I'm happy to take some questions or have some conversation going on. So if you want to post some questions, I'm happy to have some conversation and some social. Otherwise, I may just wrap it up. Now I'm ready for the rest of the weekend. Yeah, good luck with that. After all of this. Okay. What do we have going on here? Oh, wait. Dan Schiffman is live. Well, Dan Schiffman has been live since 4 p.m. All right. I think I'm going to go check out Dan Schiffman. All right. So, well, if there are no questions, thank you very much, everyone. Thanks for sticking around. I really appreciate it. It makes writing these tutorials and recording them much, much more enjoyable. And I appreciate getting to know some of you through your comments and through the offline Discord live. Okay. I hope this was useful. I think this is probably going to finish the Intro to C# series. I think I'm just going to call it with this one. I may, next time we record, I may make a couple of small pieces about like an introductory video and like a wrap-up video. And then after that, we can go back to our regular rhythm of geometry gems, algorithmic modeling, and go back to more like perhaps like Rhino and Grasshopper based stuff. I have the Learning Grasshopper playlist that is only halfway through, so I may want to pick that up at some point soon. But in the meantime, if you want to, I'm a little bit out of topics, at least geometry gem and that kind of stuff. So if you have ideas of what you would like to see, feel free to go to Discord and to go to topic suggestions and maybe chat about things that you would like to see, algorithms, etc. And then I might give it a look. Okay. Otherwise, thanks a lot for sticking around. It was a pleasure as usual, and I'll see you next time. Bye bye. Have a good weekend.